didn't skip more clothes. Hello and welcome to the last part of this introductory section to our energy storage course and on the 3 pillars for 100% energy supply with renewable energy. We already had been talking about the first 2 pillars, and one was storage, the other overproduction. And now we are discussing the role of having just more grid solution. And I think you all remember, it's already now some years ago and nobody talks anymore about this Desertec project. But there it was the idea to connect all Europe, parts of North Africa, the Middle East, and going maybe even up to Asia with a large overlay grid, a high voltage DC grid that might then much better balance our electricity production from sun and wind with our consumption needs. I don't want to talk too much about Desertec, but I use another work, a PhD thesis from Gregor Zisch. He made a quite similar study covering all those parts of Europe, Africa, Asia and the Middle East with overlay grids, and did a very detailed study of that map. And what is quite interesting, what you see on that map is all the year, and it's the 90 daily mean production from wind power, and only from those countries that you can see on the map that are attached here to the North Sea. So it's the Great Britain island, it is Scandinavia, it is France, Benelux, and it's Germany and Denmark. And then you see the main problem. Definitely there might be a balance from 1 hour to the other, from one day to the other between those countries. But all have the same characteristic. In winter we have a lot of wind power production, but in summer we have a lack of wind power production. And when we now take into account all parts indicated on the map on the left side, and then we see quite different characteristics. For example, in the northwestern part of Africa, or even in that part indicated with number 9 going more to Siberia, then we have the other seasonal pattern of wind power generation. And the thick black line is then the mean of all those regions. And then we see we never have a zero or a close to zero wind power production. Here the minimum is still more than 20% of the rated power. And also the maximum power that needs to be transmitted is not anymore close to 90%. It is just down with a bit more than 40%. So it is much more balanced. So it's a quite good idea having such a grid. But it's not the only thing. So maybe those grids can have a good effort, but please not like the former EU Commissioner for Energy, Günther Oettinger. He said, we only need to have solar in North Africa and South Europe, and wind we do only on the Atlantic coast, and the rest is done by grid, and in Germany we do nothing. For sure it's not a good idea. Why not? And I would like to explain that on what happened in reality, and that was Italy in the year 2003. What happened in 2003 in Italy? We had a situation where Italy had a very big power import, mainly from France, but via Switzerland and directly from France. And all the lines you can see on that map had been quite highly loaded, and there was a drop out of one line to a connection to a tree from Switzerland to Italy. So the line dropped out, as it is planned in such cases. And then the problem has been that the power now was distributed to all the other lines, immediately causing the problem that line number 2, again between Switzerland and Italy, dropped out because of an overload. The remaining load was distributed to the rest, and so one line after the other dropped out because it was overloaded, and then we had a voltage collapse in Italy, and Italy had a blackout in some parts of the country up to 24 hours, even more than 24 hours. And that is exactly what happens when the own power generation in a region, in a country, is not sufficient to cover the own needs. So whatever we will do in future by balancing our consumption and generation better by grids, maybe even covering all Europe, maybe even a part of Africa and even a part of Asia, we always need to have a decentralized generation capacity or a storage capacity in order, when we have problems with the lines, we are not running in very big blackout situations. So therefore, grids maybe can optimize the power generation and distribution on an economic basis, maybe, but it cannot be the only solution. Another good example shows what happened in Europe. It was in 2006 when a big cruiser ship wanted to leave Germany towards the North Sea, and it was planned to switch off a line that the ship can pass below that line. But some calculations had been wrong, and again the same happened. The power was distributed to other lines and another one was overloaded, and so Europe had been split again as a domino effect into 3 parts. But this time nothing happened, or it was not a big problem. For example, when we look to the orange Western European part, due to some load shedding, for example, my city Cologne had been dark but planned dark for around 20 minutes, or by activating some stored hydropower systems, the system could have been kept stable, and after a while the 3 parts of Europe resynchronized, and by that means, because in every part, in the western, in the eastern and in the southeastern part, was enough generation capacity, enough storage capacity, we could prevent blackout. And therefore, when looking for our last pillar, the grid extension, the red arc is not going to the end. So grid extension for sure maybe can play a big and an important role in going towards a 100% renewable power generation. But it cannot be the only solution, because grids only can make a shift in place, but grids cannot, like storage, make a shift in time. I don't know where is the ideal solution. The solution layer we see here, it is a quite big possibility from energy storage and overproduction, and a quite big part, but not all the part, from grid extension. And maybe the optimum in future will be, we need all of them. We need new grids, we need storage, and we also will have overproduction, and maybe we find the optimum somewhere here in the center. Nevertheless, energy storage will play a big role, and that is what our course here in the next months will be about. So thank you very much, and then we continue next week with the classification of different energy storage systems. Have a nice day.